Alright, so we're going to be adding and subtracting polynomials. Now, as you can see, there's a few things that we have to learn about polynomials before we start adding and subtracting. So, monomial. Monomial is a form of a polynomial. And here's a few examples. So we could use any number. So, like a number 8, right? Any number, 8, negative 15, 35, doesn't matter. Just a number by itself is a monomial. We can use a number with a variable next to it. Alright, so 4 times x is a monomial. Even though there's two things there, they're together, so it's a monomial. I can throw a fraction in there. So 3/4 x squared y to the third. Even though I have variables with some exponents, and there's 3 things there, it's still a monomial because it's all together. And then we could throw a negative decimal in there, 4.2 xy. Alright, so those are all examples of monomials, and there's an infinite amount of examples we can come up with. Now, degree. I'm just going to start writing the answer, and let's see if you can come up with y. So for 8, the degree is 0. For 4x, the degree is 1. For 3/4 x to 3/4 x squared y to the third, the degree is 5. For this one, the degree is 2. Now, this one right here, the 3/4 x, the 3/4 x might have been a giveaway. We could do, all we're doing is we're adding the exponents together. So 2 plus 3 gives us that 5. So the negative 4.2 xy, we get that because the exponents are 1 and 1. So 1 plus 1. And then right here, the degree is 1 because we just have one exponent of 1. But for 8, we have a 0, and that's just because there is no variable whatsoever. Alright, so when there's no variable, the degree is 0. Alright, so some things that are not a monomial. Y minus 6 is not a monomial. This thing has 2 terms. And since I said the word terms, let's talk about it. The y is one term, and this negative 6 is another term. Alright, so there's 2 terms. Terms are separated by the terms are separated by a plus or a minus sign. So there's the term right to the y, to the left of the negative. That's that's one term, and then the term to the right of the negative is another one. 2 over x is not a monomial because we can't have, right? So no variables in the denominator's position. Right? No variables in the denominator. 3 to the x. This is not a monomial either because no variables in the exponent's position. Alright, so no variables in the exponent position. And then x to the negative 2. This is not a variable, this is not a monomial, even though it was one term. It's not a monomial because the exponent must be positive. The exponent must be positive. Sorry for squeezing that in there, but the exponent must be positive. Okay, so now let's do some examples. So example 1. Example 1. Find the degree of the monomial. So if I gave you 2x, well, the degree, what's the exponent on x? The exponent is 1, so the degree is 1. Look at part B. Negative 2/3 x to the 5th y z squared. Well, the degree here, remember now we talked about the degree, looking at all the exponents. Add all the exponents up. 5 from the x, 1 from the y, 2 from the z. So the degree here is 8. Right? Here's 2 more for you. You guys try them real quick. xy squared and d negative 15. Right. The degree for xy squared is 3. Recall, the exponent on x is 1, and then the exponent on y is 2. So 1 plus 2 gives us that 3. And then, because negative 15 does not have a variable, the degree is 0. Alright, so a few things now we need to talk about. When we're talking about polynomials, right, we have, and polynomial just means many terms. So a binomial. A binomial, if you recall from the example with not a monomial, 2 terms. So think of bi. So bicycle having 2 tires. Binomial is going to have 2 terms. Okay, so 2 terms. 2 terms. So an example would be 3x plus 5. And then we have a trinomial. Alright, think of tricycle. Tricycle has 3 tires. So a trinomial would have 3 terms. An example of a trinomial could be 3x squared minus 4x plus 5. So there would be an example of a trinomial. And then we have to start talking about a degree of a polynomial. Not just a degree of a monomial, but a degree of a whole polynomial. And all a degree of a polynomial, all that entails is we want to find the biggest degree of all the terms. Okay? So you look at all the terms, you add up all the exponents for each individual term, and whatever the biggest number you get is the biggest degree that you get is the degree of the whole polynomial. And then standard form. Standard form just means we're looking at the exponents from smallest to biggest. Oh, excuse me, I apologize. It's from biggest to smallest. Okay? Excuse me for that. The exponent is from biggest to smallest. So we look at the biggest exponent and you work your way down to the smallest exponent. So example 3. Oh, excuse me, example 2. We want to write a polynomial. We want to write a polynomial in standard form and then we want to identify the degree, the leading coefficient, and I'll talk about that in a second. You guys already know what coefficient is. It's the number in front of a variable. So we want the leading coefficient and classify each polynomial by the number of terms. Alright, there's a lot of directions for problems that are not that difficult. Alright, first example. If I gave you 7x squared minus 6x to the third. First thing we want to do is put it in standard form. Alright, so standard form means from the biggest exponent to the smallest exponent. Well, I'm looking at the biggest, and then here's the smallest. So 6x to the third is negative, so that negative comes along with it. 6x to the third. 7x squared is positive, so I put a plus 7x squared. So the signs that are in front of it follow it. Right? The signs follow. Now, I want to identify the leading coefficient. Right, the leading coefficient. Oh, I didn't spell that correct. I don't know if it's still spelled correctly or not, but there you go. Leading coefficient. Well, the leading coefficient is merely that -6. The sign comes along with it. Right? And later on I'll just be using LC for leading coefficient. And then we want the type. What kind of polynomial is this? What kind of polynomial is this? 2 terms? So it's a binomial. Okay? So again, a lot of directions for problems that aren't too difficult. Here's the next one. -4y squared plus 2y to the 4th plus y to the 5th. Alright, so standard form. So standard form, a little shorthand. What do? Alright, you should be telling yourself biggest exponent to the smallest exponent. So biggest exponent is the 5. So y to the 5th plus 2y to the 4th minus 4y squared. Right? So you look at the exponents, 5, 4, and then 2. And you notice the signs go along with it. That 4y squared was negative. Over here, it's still negative right there. Alright. Oh, we forgot for part A. We forgot the degree. I apologize. Let's go back. The degree was merely 3. Okay, I apologize, I forgot. So what happens to the degree here? The degree here is, yep, that's all, just 5. The leading coefficient, again, I'm just going to use LC for leading coefficient. Leading coefficient, what number's in front? A 1. And we're done. And then type, what kind of polynomial is it? Well, there are 3 terms. There's 1, 2, and 3. 3 terms, it's a trinomial. Alright, and then last one for this, 8x to the 10th. Standard form. Can we do anything with it? Is there anything I can do with that standard to change it into standard form? No, it's already in standard form. What about the degree? The degree is, yep, we just look at the exponent. The degree is 10. Leading coefficient, again, just LC for leading coefficient. Well, there's only one coefficient, and it's an 8. And then the type. How many terms are there? 1, so it's a monomial. Alright? So, not difficult, just quite a bit of direction writing, but I don't think it's difficult. And example 3, find the sum. So I'm going to give you some polynomials. 3x squared plus 4x plus 3 plus. And you'll notice that first polynomial, or trinomial, because there's 3 terms, is in standard form. Plus 2x plus 5x squared plus 1. This one is not in standard form. The second term, the second polynomial, or the second trinomial, is not in standard form. But if we want to find the sum, if we're going to add them, okay, if we're going to add them together, it's not that big of a deal. It's not that big of a deal if they're not in standard form. We look and see what's the biggest exponent, right? And they call this a horizontal method. They call this a horizontal method of adding. And it's fairly simple because you're just combining like terms. And remember, what does it mean to be a like term? Like term is just same variable, so 3x to the second power, 5x to the second power. So like terms are same base raised to the same power. So the variable has to be the same, the exponent has to be the same. 3x squared plus 5x squared, 8x squared. You notice I did not change the exponent. I cannot emphasize that enough. Do not change the exponent. And now we go down in standard form. So 4x, because it's x to the first, and 2x. You notice I'm putting 2 lines under the x term just for grouping purposes. So 4x plus 2x, 6x. And then our constants, right? The numbers that are not going to change. 3 plus 1 gives us 4. So that's a horizontal method of adding these. A vertical method, just like the way it sounds. So vertical, exactly the way it sounds. We stack them on top of each other. 3x squared plus 4x plus 3. Now I take the second trinomial and I want to keep like terms together. Alright, so I'm going to keep everything in columns. So I'm going to take this 5x squared here, and I'm going to put it under the 3x squared, and then go down in value for x's, for the exponents, keeping everything like all the like terms together. Okay, so there's a vertical. Now I just look at 3 plus 5 gives me 8x squared. Again, I cannot say this enough. Do not change the exponent. X squared gives me x squared. Alright, 4x plus 2x, 6x. 3 plus 1 gives me 4. And you'll notice the answers are exactly the same. So whichever way you're more comfortable doing it. Okay, it's entirely up to you. Whatever way you're comfortable doing this problem. Alright, part B. Negative 5y squared plus y plus 2 plus 2y squared minus y minus 9. Alright, they're both in standard form. And if we do it horizontally, like terms, negative 5y squared, 2y squared is negative 3y squared. Y to the first, another y to the first, so I put 2 lines under it. And recall, some of you guys need to write that 1 in front for yourselves. Some of you need to write that 1 in front. So 1y minus 1y, 0y. Do not put y. If you put y, that's telling me there's 1 there. So we leave it blank. We leave it alone. And then we have our constants. 2 minus 9, negative 7. Alright? Now if you want to do it vertically, we're just setting these on top of each other. 5y squared plus y plus 2. And then we have 2y squared minus y minus 9. Again, I'm not picky which way you do it. Whichever way you're more comfortable, whichever way you think you're going to get the answer correct. Negative 5 plus 2, negative 3y squared. You'll notice these cancel each other out. Minus 7. Alright. Last one. And I want you to give it a try. Alright, so when I'm done writing it, hit pause. You give it a try. T to the third minus 4t plus 6, close the parenthesis, plus 3t squared minus 10t minus 5. Alright, you hit pause, try it, and then when you got it, I'm going to have the answer written for you. Alright, so go ahead, hit pause, you try. Alright, hopefully you've given it a try yourself, and you'll notice there's only this one t to the third. Over here, nowhere over here was there a t to the third. There was no t to the thirds at all. So I have t to the third. Then I have a t squared. Nowhere in this polynomial. Nowhere over here do I have a t squared. So I write plus 3t squared minus 4t. Let me erase that line. Alright, so negative 4t minus 10t minus 14t. And then our constants, plus 6 minus 5 gives me plus 1. Alright, So you'll see what happens when you don't have the same amount of terms. All right? If you wanted to line it up vertically, you'll have to do a little bit of adjusting. So you'll have t to the third. Since there's no t squared, you're going to have to leave some space and write minus 4t plus 6. You get down to the second trinomial. There's no t to the third, so now you're going to write 3t squared minus 10t minus 5. Okay? So tried to trick you a little bit, but I think you guys are good.